Welcome viewers. Today we are going to discuss the concepts of half subtractor and full subtractor. The subtractor is used to carry out subtraction of binary numbers in digital electronics. Subtractors are of two types, half subtractor and full subtractor. In half subtractor, there are two inputs, subtrahend A and minuend B, and two outputs, difference and borrow. In full subtractor, there are three inputs, A, B and B in, and two outputs, difference and borrow out. First, let's discuss what a half subtractor is. A half subtractor is a combinational circuit which subtracts one binary digit A from another B, generating difference and borrow outputs. When both inputs A and B are 0, subtracting which difference is 0 and borrow is also 0. When inputs A is 0, B is 1, subtracting which difference is 1 as well as borrow is 1. When inputs A is 1, B is 0, subtracting which difference is 1, borrow is 0. When both inputs A and B are 1, subtracting which difference is 0 as well as borrow is also 0. This is shown with a table called the truth table of half subtractor. On realizing the K-map of the truth table, we can implement the Boolean expression. From the K-map, the Boolean expressions are: difference is A not B plus B not A, which is A XOR B, and borrow is A not B. The above Boolean expressions are then implemented in the circuit diagram. When A and B are passed through XOR gate, the difference output is generated. When A is then complemented by using a NOT gate and then passed with B input through the AND gate, then the borrow is generated. Now let's discuss the full subtractor. A full subtractor is also used to perform subtraction between three binary inputs A and B as well as B in. When inputs A is equal to 0, B is equal to 0 and B in is equal to 0, then outputs generated are difference is equal to 0 as well as borrow is equal to 0. When inputs A is equal to 0, B is equal to 0 and B in is equal to 1, then outputs generated are difference is equal to 1 as well as borrow is equal to 1 as well. Similarly, the rest of the conditions will be this is shown with the truth table. From the K-map, we can implement the Boolean expression. Difference is equal to B in not A not B plus B in not A B not plus B in A not B not plus B in AB. This can be simplified as difference is equal to B in XOR A XOR B. The borrow is equal to A not B plus B B in plus A not B in. This can also be simplified as borrow is equal to A not B plus B in A XOR B. This could be implemented using a circuit diagram. Observe carefully when inputs A, B and B in are passed through the XOR gate, the output difference is generated. When inputs A naught, B and B in are passed through the AND gate as well as the OR gate, the output borrow is generated. In this lecture, we have learned basic description of the half subtractor and full subtractor, truth table, K-map and Boolean expression implementation of the half subtractor and full subtractor, circuit diagram of the half subtractor and the full subtractor. With that, we are at the end of this lecture. In the next lecture, we will meet again. Till then, practice the relations repeatedly. Goodbye and thank you.